Guys, in this video we'll be discussing about internet protocol and let's just enter the Wireshark Lab of internet protocol. So to give you a brief idea about what's the internet protocol, it's a protocol that communicates and facilitates the transmission of data between two devices on a network by providing the addressing and the routing information. Okay. Now, as you might have understood of what IP protocol is, let's just start capturing the packets from an execution of a trace route. Uh, in this, in the Mac OS, you can use a trace route command. For example, if you just wanna trace route this particular website, and you must do it in the three ways, like. First, you have to do it at the length of 56 byte, and second in the 2000 byte, and third in the 3500 bytes. So this same website has been done already in the Wireshark zip folder. Like in the previous videos, we have installed the zip folder, right? So the same command has been done manually. So we just don't need to do it again. So now open Wireshark and open IP Ethernet trace, right? Yeah, once you have entered into the IP Ethernet trace one packet, uh, now just start by answering the question. Like select the first ICMP echo request message sent by your computer and expand the internet protocol packet part in the details window. So what we have to do is, first let's select the IMCP protocol, right? Yeah, this is the first IMCP protocol, and in the source path is the IP address of my computer. So second question, within the IP packet header, what's the value in the upper layer protocol field? So in the upper layer protocol field, it is ICMP. Okay. And next question, and what's the value of the protocol field? The value was 1, and it's an ICMP protocol. So the next question, how many bytes are in IP header and how many bytes are in payload of the IP datagram? So for this, first we have to find the bytes in IP header, right? So once, if you see over here, the length is as 20 bytes, right? So the bytes are 20, and to find the payload of the IP datagram and its bytes, you just have to subtract this value from this value. See, let's say um, 84 minus 20 is 64, right? 84 minus 20 is 64, right? So the maximum number of payload of the IP datagram and the maximum number of the payload data bytes are 64. So in this way you calculate that. And the next question, has this datagram been fragmented? And explain how you determine whether or not the datagram has been fragmented or not. See, actually, the datagram is not fragmented, and you can say it from this. See, over here, it has been in the fragments, more fragment section, it is shown like it's not set. So, if the fragment is set, then the datagram is fragmented. Otherwise, the datagram is not fragmented. So in this case, it's not set, so it's not fragmented. And next question. Now sort the packets according to IP source by clicking to uh, by clicking in the source protocol. So next what we would do is that just go to the Wireshark packets captured, right? Now go over here in the source, yeah, like just now modify it with this thing, yeah, and now we have got these are arranged in a sorting manner. So now over here, the first thing, what is the question? Let's see it again. Which fields in the IP datagram always change from one datagram to next within this series of ICMP messages sent by your computer? So in this first thing, see there are three things which do change frequently, and that is identification and time to TTL value and the header checksum. These three things often change from one ICMP to another ICMP. See, for example, let's see for this thing, it is a 13,008 and TTL is 1 and it is 0x2D to C. So for this, again check it. It has been changed. CM goes to this and same goes to this. And similarly this one, this one, this one, this one. It has been continuously changing, right? So these things are changing from one datagram to another one. So next question. Which field stays constant and which of this field must stay constant and which fields must change and why? See, in the previous question, we have done it right. So the identification field and TTL and header checksum field must be changed often, and which field must stay constant, and we can say that as a source address. See over here, anything might have changed but not the source path, destination part, header length, and the IP version, right? So these four are things that doesn't change often, and TTL, identification, and header checksum are the things that change often. Describe the pattern you see in the values of the identification field of the IP datagram. Okay, see for the first one, wait a second. Yeah, for the first one, identification is 13,008, and second one is increased by 1, and third one is by 1, 1, 1, 1, 1, 1, 1, and it goes on increasing like adding 1 to the next datagram. So the answer is it has been increasing by 1. And next question. Now again sort it in the series of ICMP TTL. Okay. Now again sort it in the terms of protocols, right? Yeah, we have sorted it. So let's just sort it according to the destination port, and again we'll just sort it up. We must do it until and unless we get it in an order type. See over here, wait a minute. Yeah, now these are sorted according to the ICMP things, and now let's just say what's the first ICMP echo message that let's just move into the questions. And what's the first ICMP message request that was sent by your computer after you changed the packet size to 2000? Okay, so when we must see on what thing the data has been changed to 2000, and yeah, and we must see whether it has been fragmented more than once or not. So over here, if you go over here, if you go over here, you might like again change it in terms of this. Yeah, over here, first thing has a data byte of let's hold on a second. Yeah, in the Internet Control Message Protocol, the data bytes is shown as 56, and similarly over here 56, and over here also 56, and over here also 56. So we must see in which segment does the data byte increases to 2000. So in the 93, yeah, wait a second, let's just, yeah, in the 93 segment, the data has been changed to 2000 bytes. So this is the first ICMP protocol where the packet size has been changed to 2000, and has a message been fragmented more than once in a IP datagram. That we can do it, like we can check it. See, there are two fragments, right? So it has been fragmented more than once, and the number is 2. So moving to the next question, print out the first fragment of the fragmented IP datagram, and what information in the IP header indicates that the datagram has been fragmented, and what information, yeah, firstly, wait a second, yeah, now firstly we just have to print the first fragment of the fragmented IP datagram. Over here, the first thing is frame number 92, and the second is frame number 93. So firstly we just have to go to frame number 92, and over here we just we can print it like go to the file, print, yeah, and you get the print thing. You get the selected packet. See, I've just selected this thing, right? So you can just print it from here, or you can just print it like over here also. Let me just show you uh, this thing. Just open everything, not this, open right DTL and the data length, yeah, and now screenshot it. This might be the printing thing that you required for the question. And what information in the IP header indicates that the datagram has been fragmented or not. So in this, if you just see, the datagram is been fragmented because it has been set to 1, right? If it is not set, it's not fragmented. If it is set to 1, it's been fragmented. So, and what information in the IP header indicates whether the first fragment versus a lateral fragment, uh, and how long is the IP datagram, and the IP datagram, how long, right? We can just get it by the length of 1480, and this is the length of the datagram of the 90-second frame, which is 1480. And move forward to the next question. Print out the second fragment of the fragmented IP datagram. And yeah, the 93rd port, right? The second fragment was the 93rd port. Now select the 93rd port and again just completely open it, or you can just print it from the file print and the selected packets only, and you can do it. So, and what information does the IP header indicates that is not in the first datagram fragment? Are there more fragments, and how can you tell? See, for this question, yeah, in this, the fragment is set to 0, but in the previous one, 92second one, the fragment is set to 1. So this is a change between the difference between the 92nd frame and the 93rd frame. And are there more fragments? There are no more fragments, because in this there is only frame 92 and 93, right? So there is only two, and there are not more than two. And that's it. Moving forward to the next question. What fields change in the IP header between the first segment and the second segments? Uh, the fields that changed between the first and the second fragment was the total length. See, over here, the total length. For the 92nd one, it is total length is 1500, and for the 93rd one, it's 548. So that's the first thing which has been changed. And the flags for this were set to 1, and for the 93rd frame was set to 0. And again, similar to this one, the fragment offset is 0 and the fragment offset is 1480, and more fragments. And so what we can totally what fields change in the IPA header between the first and the second fragment was total length, flags, more fragments, and the fragment offset. And again, moving further, again find the first ICMP echo message that was sent by your computer, where the packet size is 3500. Okay. Now again, we just have to look it up where the size is more, and we'll just do it by, see over here the data byte is 56. Again, just select some random thing and just verify it. The same, it's 2000. Yeah, and 225, 222, and 218, 205. Yeah, 218 is a fragment where the length has been changed to 3500 bytes, right? So yeah, and let's answer the question. How many fragments were created from the original datagram? See, we just have to see over here how many fragments are there. There are three fragments known as 216, 217, and 218. See, 216, 217, and 218 were the three fragments. What fields change in the IP datagram among the first three fragments? See, you just have to verify it. Over here in the 216, TTL is 1. In the T17, TTL is 1. And see, similarly, the fragment offset in the 216, more fragments were set to 1. And over here, the more fragments were also set to 1. And over here, the more fragments were not set. So the more fragments might have been the same in two, but it has been changed to in the third one, right? So that thing, and the fragment offset, which is 2920 960 for the third one, and 1480 for the second one, and 0 for the first one. So this is another thing that has been different from it. And the flags, and even the flags, see over here the flags were set to 01, and the flags were set to 01 over here also, and over here 00. So even this is different from each other. And now finally the total length. See, the total length of it is 568 for the third one, and 1500 for the second one, and 1500 for the first one. So these have been changed multiple times. So the only thing which was constant is that TTL value, and that's it. Thank you guys.